Our topic was web service security. In this paper, we researched several forms of web service security, including JSON web tokens used in authentication, injection attack detection, a fuzzy-based intrusion tolerance method, and authorization.
Here, I would like to discuss about JSON Web Tokens. The idea behind token-based authentication is allowing clients to input their login and password to get a token which permits them to get a particular resource. After receiving the token, the consumer can send a token in the request which grants permission to resources within a certain time frame. The JWT has been created on the server with an algorithm. Looking inside the token, one may know who the owner is and access rights handled by the client. A JSON Web Token, or JWT, is a dense URL-safe manner of embodying claims to be exchanged between two participants. The claims are encoded as a JSON object in a JWT and used as the payload of a JSON Web Signature, or JWS, construct, enabling the claims to be signed digitally or have the integrity protected with a message authentication code. The JWT string contains three components, which are the header, the payload, and signature, each portion separated by a period. JWT header contains information about the signature. The header contains the hash algorithm used to create the JWT signature. JWT payload has pieces of information saved inside the JWT, such as subject, name, issued at timestamp, and expiration timestamp. And the JWT signature has the signature of header and payload, which is calculated by encoding the hash data of the header and payload. Basically, the JWT mechanism conducts the following steps for client-server authentication as shown in this figure. Number one, the user sends an authentication request by sending a set of credentials such as username and password combination. Number two, after validating the user's credentials, the authentication service generates a JWT from the obtained user authorization information. The created token is then returned to the user for additional requests to the protected resources on the application server. Number three, the user can utilize this token with a request to a protected resource on the server, usually attached in the request header. And number four, the server obtains the request, unloads the authentication data from JWT, and validates whether the request is indeed valid and authentic or not. The server will then send an appropriate response to the client based on valid or invalid token. JWT provides many pros to web services. JWT is a scalable solution with outstanding performance benefits for user access control and decentralized, large-scale distributed systems. The main highlight of JWT is the fact that it permits the state transition to the transmission. Therefore, a user does not have the ability to modify the data stored inside the token. Other advantages include fewer database queries, and JWT can be used across services. When it comes to database connections, the authentication server may only need to access the database once to verify given user credentials are valid, passing a UUID back to the client for future requests. This implies shorter latency and reduced costs if using paid database services such as Amazon DynamoDB. When it comes to functionality across services, engineers may have one authorization server that manages login attempts and creates the token, allowing clients to pass the generated JWT for the subsequent request and not have to call the authorization server again, nor connect to a database until the token expires. On the other hand, there are some cons to using JWT for web service security as well. One disadvantage of using this standard method is that the server utilizes the same JWT for all future requests until the user logs out of the system. Other cons include the risk of compromised secret keys and data overhead. In the case of a leaked secret key, the entire system would be compromised, and the situation will force engineers to generate a new secret key. As a result, all existing client tokens would be unauthenticated, and users would have to invoke the authentication web service once again to retrieve a valid JWT. For the disadvantage of overhead, the more data the JWT contains, the longer it might take the JWT to be sent through the network, especially for low-speed connections. It is recommended to make JWT payload as little as possible to help with performance.
I researched 4 different papers. They covered injection attack detection. The first paper was intrusion detection system. The second, remove parameter values for comparison. The third, additional web services for query analysis. These 3 papers were theoretical and they did not do any testing. The fourth paper covered the last 2 topics, which are commercial penetration testing tools and commercial static code analyzers. These researchers presented their test results. The first method is an intrusion detection system. The researchers proposed an automated intrusion detection system that works in conjunction with existing web scanner tools to improve their ability to test web services. The algorithm they used is called genetic algorithm, and they used it to generate test messages for XPath, SQL, and SOAP messages. The algorithm enabled them to make slight mutations in order to create many variations of attacks. In order to create these types of tests manually would be extremely labor-intensive. The researchers' evaluation shows that detection rate improves as the sample size increases. The advantages they listed were its automation and cost effectiveness. It has versatility in that it detects simple as well as complex attacks, and it covers various message types. The next method involves removing parameter values for comparison. The researchers proposed a method to detect SQL injection attacks by removing parameter values of the SQL queries at runtime, then comparing them with static queries prior to execution. If the queries match, that would mean it's okay. Otherwise, it is abnormal and could be a SQL injection attack. Their method would make applications more secure by being able to detect injection attacks. A disadvantage of this method is that it requires access to the source code. The third method requires additional web services for query analysis. Researchers proposed 3 different web services for input validation. The first service retrieves the user input from a form and passes it to another service to be filtered for vulnerabilities. If the results match attack patterns, the request is denied. Otherwise, the request is passed on to a third service. Also, when the requests are denied, only general error messages are returned. This is so sensitive information will not be passed to users. An advantage of the system is that it would be cost-effective, but it could only be used for SQL attacks. The fourth method involves commercial penetration testing tools. These tools can be used to scan web services to discover their weaknesses. In this paper, researchers tested 3 different testing tools. The web service code was first analyzed by a team of security experts. The tools were executed on the code and the results compared with the expert findings. Results showed that none of the tools were over 51% as effective as the expert analysis. False positives were also recorded. The advantage these tools have over manual analysis is since they are automated, it is more cost-effective. A disadvantage is that they are not always as effective as evaluation by experts. The fifth method was commercial static code analyzers. 3 commercial products were compared by researchers to evaluate their effectiveness. One of the tools provided 100% code coverage and found the same vulnerabilities that the expert team did. The other 2 tools were less effective. One of the tools had very low code coverage. All of the static analysis tools detected false positives, and the expert team did not. The advantages of these products are that they are automated and cost-effective. They can provide a high percentage of code coverage. The disadvantage is they sometimes present false positives.
Hi, I am Srikanth Ramakrishna and I'll be speaking about intrusion tolerance as part of the web service research paper. What is intrusion tolerance? Intrusion tolerance is identifying threats to the system while requirements are being gathered. The approach leads to a fault-tolerant model for security requirements. In short, this phase is about identifying threats during the requirement gathering phase of your project. For example, let's consider a system that is used for securing user credentials and payment information in a typical web application. The actors in blue is the real client we need to service, while the actor in black is the unauthorized entity or the attacker. The use cases in white are security use cases. The ones that are in green or orange is vulnerability, which means an attacker can exploit this vulnerability, while the security use cases would say, how do I mitigate those vulnerabilities? For example, it will say protect credit card information. If the vulnerabilities don't protect credit card information, then this exploit would use it, while the protect credit card security use cases would mitigate this. Now, how do we do this? Let's move on to the next model, which is the interesting part, which is mitigation model. Let's, for the sake of this presentation, identify ourselves to a small use case of protecting the username passwords. So requirement 1.3 would say avoid online access to info or unauthorized access to online info, which means nobody should have unauthorized access. How do I do it? I will do that with addressing requirement 1.3.1, which is avoid stealing ID and password, and avoid ID and password by guessing. So got to avoid both ways of accessing. And how do I prevent ID being guessed? So I should avoid by a dictionary attack or brute forcing. So these requirements 1.3.2.1 and 1.3.2.2 both address the vulnerability of having ID and password that are guessable. It also mentions a side requirement making don't try to make the thing so hard to guess that the user will have a hard time setting it or using it. So it also specifies that boundary as well. Now if I take just the dictionary attack avoidance use case, it will say how do I avoid the use case by having guessable ID, by having a random ID generated that makes the ID difficult for a dictionary attack. Similarly, for the password, to prevent a dictionary attack, what I could be do or what should be done is implement a password policy and encrypt password. So as you can see, just to avoid dictionary attack, which is already identified in the requirement gathering phase, it says you have to make the ID a random ID and the password has to have a requirement expiry policy, and also the passwords have to be encrypted. On the other requirement of how to avoid brute forcing, it also says guess password by brute force has to be avoided, and the guess ID has to be resilient for brute force attack. And how do you achieve them is by generating a random ID for the user ID or the guest ID and having the trial limitation for guessing the password. This will prevent brute force attack. So what this whole slide shows is, it shows what are the vulnerabilities in the requirement and how the mitigation that are to be done to close those security vulnerabilities. Now, Moving on to the pros and cons of this approach. Since the security is defined as part of the requirements, it generally leads to a more secure, fault tolerant system, because the requirement phase itself is looking at every requirement and trying to figure out if there are any vulnerabilities in it and how to mitigate them, and this leaves less to interpretations during the design phase of things. However, on the con side of it, requirement gathering phase is extended, because now the first phase you have to think of all the vulnerabilities and possible mitigations to it. However, not all cases can be thought of at the requirement gathering phase, since designs and requirements evolve over time. Thank you.
There are many different types of authorization. A few that will be discussed here are role, claim, and resource-based. For role-based, roles are defined in the web service, and users are assigned to one or many roles. That web service then restricts resources based off the specific roles of an endpoint. Claims are key-value pairs that represent what a subject is. This type will check the value of a claim and allow access to a web service resource by that value. From there, it's easy to guess what resource-based authorization is like. This type of authorization is restricted based on the resource that is provided, not based off the role of the claim. So you can have many users that are authors of documents and can read each document, but only the document that they author are they allowed to edit or delete. This is how resource-based authorization works. Here's an example of an implementation of role-based authorization. Only managers are allowed to terminate employees, so the authorized role equal to manager prevents any other employee type from terminating employees. That way, a cashier is not allowed to terminate another cashier or a manager even. Role-based authorization makes it very easy to look at an endpoint and determine who has access to process that data